Okay, so validate binary search tree. Given the root of a binary tree, determine if it is a valid binary search tree. A valid BST is defined as follows. The left subtree of a node contains only nodes with keys less than the node's key. The right subtree of a node contains only nodes with keys greater than the node's key. Both the left and right subtrees must also be binary search trees. So basically at each individual node, all the values that fall to its left need to be less, not equal, to the node's current value. So everything to the left needs to be less than 2. Everything to the right of this root node needs to be greater than 2. This is a valid BST. This one, invalid because this 3 is less than 5 and it falls on the right side. So let's see if we can do this in under 5 minutes. This can be done in a recursive fashion. So what we can do is we can make a helper method, call it isValid. We'll pass in the root node and we'll pass in integers that will be initialized to null to begin with. We'll return a Boolean to signify whether it's valid or not. So isValid, we'll take in a tree node, and it'll take in a integer min and integer max. If the node is null, well, let's just return true because that is valid. A null value is technically valid for our intents and purposes. What we want to do really quick is do a check to see if it's invalid. So if the min value, that means these values are the ones that fall to its left. If node.val is less than or equal to min, then we can return false. But we also need to do a null check. So let's check that integer, the min integer, is not equal to null, and then check whether node.val is less than or equal to. We'll do the same thing with max. Do a null check, and we'll check if node.val is greater than or equal to anything greater than the max value. So next, what we can do is just do a recursive call on the node's left and right pointers. So we can do return isValid node.left. And so basically, as we go to the drop to its left, we are going to want to pass the node's current value down to its left child nodes and set that as the max value. So we can still pass in the min that we have, but the max will now be node.val. And then we will do the same thing with the right children, with the right child. So we'll pass in node.right, and we'll pass in node.currentVal as the new min, because we do not want anything on its right side to drop below its current value. So 3 should not drop. 3 will fail this test because 3 should not drop below 5 and to make this BST valid. That'll be the new min, and we can just pass in max that we had above. Let's see, let's run this test against, okay, this test pass. We can run this other one. Let's pass this in as the input from the example given. That passes. Submit it. Cool. Let's see, I think that's it.